Hello everyone, I am Dhruti Mistry. Welcome back to our channel. Today I am going to explain you one of the most important topic of CPU organization, that is instruction cycle. In today's session, you will learn what is instruction cycle, how it is related to the machine cycle. We will also discuss some fundamental concepts such as what are program instructions, its format, and last, stepwise representation of instruction cycle. The instruction cycle is the time required by the CPU to execute one single instruction. The instruction cycle is the basic operation of the CPU, which consists of three steps: fetch, decode, and execute. The program instructions are stored into the main memory RAM. The processor initiates the program execution by fetching the machine instructions one by one from the main memory. In order to understand the instruction cycle, it is important to first understand some related topics before we start the discussion on the concept of instruction cycle. So let's first start with some basic fundamental important concepts necessary to understand how machine cycle or instruction cycle works. The computer system needs a set of instructions which directs the computer to perform the desired operations. This set of instructions which computer can interpret and execute is called a computer program. The computer program written in any high-level programming language needs to be converted into machine-readable format, and it is in binary. The machine code instructions in binary is low-level set of program instructions that can be directly executed by the computer system. Now, the computer program consists of a set of program statements, also called as program instructions, and each program instruction performs a specific task. For example, the program instruction can either perform input and output operations, or arithmetic calculations, or some logical decision making operation. During the program compilation process, each program instruction is converted into machine code instruction in binary form. The computer program consists of number of instructions which directs the CPU to perform specific operation. However, the CPU needs to know the details such as which operation is to be performed and on which date. Then the CPU starts the program execution by fetching the program instructions one by one from the main memory, and the control unit of the CPU decodes the program instruction. Then the control unit of the CPU decodes the instruction based on the instruction format. It is the instruction format which provides the details of the operation to be performed and the data on which the operation is to be performed. The instruction format defines the structure of the program instruction that can be decoded by the CPU and then perform the desired operation on the data. The instruction format essentially consists of three parts, which includes OP code, operand, and addressing mode, as shown in figure. Now let's see what is machine cycle. The operating system loads the executable copy of the program code and the data that needs to be processed into the main. The main memory contains the set of program instructions in the form of machine instructions. Then the CPU starts the program execution by fetching the program instructions one by one from the main memory RAM. Then the control unit of the CPU decodes the program instruction, and then ALU executes program instructions, and last, result will be stored in memory or register. In order to perform any task, the CPU has to repetitively perform a sequence of steps. This sequence of steps is called a machine cycle. The machine cycle is a part of instruction cycle. The CPU might perform number of machine cycles to execute one single instruction, means to complete fetch, decode, and execute operations. The number of machine cycles required depends upon the type and the CPU architecture. For example, 8085 and 8086 will need different number of machine cycles to execute the same instruction. Each instruction executed by the CPU goes through different phases at each clock cycle. In order to understand the step-by-step execution of instruction cycle, let us break the cycle into series of steps initiated by the CPU to execute one instruction. Now, the first phase of instruction cycle is called a fetch phase. The instruction cycle starts with the sequence counter initialized to 0. For example, here you can see this is main memory RAM which stores number of instructions with address. Now instruction at location 002 is currently in execution mode. So next instruction to be executed will at 003 location. This address is stored in PC register. So the program counter register contains the address of the next instruction. In the first clock cycle T0, the content means address of the PC will be assigned to the address register AR. Here, AR is a register which stores address of data or instruction stored in memory. In the next clock cycle T1, the instruction is fetched from the memory and brought to the instruction register. And at the same time, the program counter PC is also incremented by 1. The program counter now points to the memory location of the next instruction to be fetched. Here you can see micro operations of the same operation at T1 clock cycle. The 16-bit instruction register format has 3 parts that includes addressing mode 15th bit, OP code 12 to 14 bits and operand address 0 to 11 bits. Next, the second phase of the instruction cycle is called a decode phase. The control unit of the CPU decodes the program instruction once it is fetched into the instruction register. Here you can see micro operation of decode phase. 3 types of instruction includes memory reference, register reference or input output instruction. The type of instruction is decoded by the 3 into 8 decoder and thus 3-bit OP code can have 8 values starting from D0 to D7 and the instruction type is decided by the value of D7. In other words, the OP code can have values D0 means 000 to D7 means 11. If the value of D7 is 0, then type of instruction is memory reference type. If the value of D7 is 1, then instruction type can either be register or input output instruction, which defines address mode. The decode phase ends after deciding the type of instruction and subsequent decision based on the value of I present in the 15th bit. Now, if the value of D7 is equals to 1 and address mode bit I is equals to 0, then the instruction type is register reference type. Else, if the value of D7 is equals to 1 and I is equals to 1, then the instruction type is input or output instruction type. Next, for memory reference instructions, the decode operation decides the addressing mode of the instruction. If the value of I is equals to 0, then addressing mode is direct, else the mode is indirect if the value of address mode bit I is equals to 1. So after completing the decode phase, the execution phase starts. In the execution phase of instruction cycle, the processor performs the desired operation on the data placed in the accumulator or any other register. And after that, the sequence counter is again initialized to 0. Here you can see this diagram is of the instruction cycle flowchart in which micro operations of all 3 phases are written and We have seen phase-wise micro-operations with example and representation in this session. That's all for today's session. Hope you like the session. Some important questions for you. First, define instruction cycle and machine cycle. Second, explain fetch phase. Then, write micro operations of decode phase. Next, write micro operations of execution phase if instruction is register reference. And last, draw diagram of 16-bit instruction format. Thank you for watching this video. Please like, share and subscribe our channel for watching more interesting videos. Thank you.